Okay, let's start again. The connection was the problem. So, said, as I said before, our today class will start chapter 3. We'll discuss components, devices used in satellite communication system. We'll discuss these components. But before we start the components, when you see satellite components, the type of components used in satellite communication system depends on first which orbit we are using. Components. When I say components, the transmitter, the receiver, what type of antenna, and equipments which are not communication equipments like power supply, control equipments. All this we'll discuss one by one, but it depends on the orbit. As we have discussed, satellites, they have different orbits. So the transmitter, for example, we use in low Earth orbit satellites. The transmitter we use in this low Earth orbit satellite. This is our low Earth orbit. Okay, I'm admitting students. So this low Earth orbit satellites, and if you compare with these geosynchronous orbits, GEO satellites, this satellite is GEO, geosynchronous orbit. The first satellite here we see is LEO, low Earth orbit. Okay, what's the difference between these two orbits? One difference is the distance, right? So this low Earth orbit satellites, the distance from Earth is from 500 kilometer up to 2000 kilometer. Okay, up to 2000 kilometer. Low Earth orbits. How about geosynchronous orbits? Distance from these geosynchronous orbits to the Earth is around 36,000 kilometers, right? So you see, the distance is different between these two orbits, LEO orbits, and one difference is the distance. So if you see the, let's compare the transmitter. The amount of transmitter power depends on what? It depends on the distance. If we need to transmit longer distance, we need high power transmitters, right? So for LEO, if you compare transmitters used for low Earth orbit satellites and transmitters used for geosynchronous satellites, the transmitter power for geo satellites, the TX power for which type of orbit? For geo satellites orbit, okay, the transmitter power must be at least greater than 10,000 times. Compare with what? Compare with the transmitter power with LEO satellites. Okay, LEO satellites. So you can see here, you can see components including transmitter, receiver. Here we take only one example, the transmitter, right? The antenna, all depends on what? Depends on orbit. The transmitter we use for low Earth orbit satellite and geo satellites are different, antenna different. So component, when we discuss components, it's not the same for all satellite systems. Some components are used for LEO satellites, some components are used for geo satellites. What's another difference between LEO and geo satellites? The speed. If you remember, last week we have discussed from Kepler's law, the speed of the satellite is inversely proportional with what? With r. What is r? This distance from the ground. Okay, so if satellites are very near to the Earth, the speed increases. That's why these LEO satellites rotates at higher speed compared with these geo satellites, because this distance is very far, 36,000. As I said, the speed of the satellite and the distance from the Earth is inversely proportional. So if you take LEO satellites, in one day, 24 hours, they rotate 3 times the Earth. Okay? In 24 hours, each 8 hours, one rotation. But when you come to geo satellites, for one rotation, it will take 24 hours. What does it mean? This satellite rotates with a speed. To complete one rotation, it will take 24 hours. Similarly, for Earth to rotate its orbit, it takes 24 hours, right? So the rotation of the satellite and the rotation of the Earth synchronized. It is the same. Okay, that's why look, you see this focus area, the area focused by this satellite, visible by this satellite, we call it footprint. It's always the same. This area always 24 hours you can access this satellite. But here for LEO satellites, this part of the Earth will access this satellite for how many hours? Only for 8 hours, because this speed is very fast compared with the speed of the Earth. After 8 hours, it will go another direction, another footprint. Okay, so as you can see here, orbit is very important. The type of components we use in satellite depends on orbit. That's the first point I want to discuss with you. Second, type of components. When I say components, communication components and control power components, but our main focus here is communication devices. But these components depends on orbit, the first point. Second point, it depends on which type of service you get from the satellite. We classify satellite services into 3 categories, right? Fixed satellite service, mobile satellite service, and broadcast satellite service. So the components we use also depends on which type of service we get from the satellite. So as we have discussed in chapter 1, fixed satellite service means we have one Earth station on the ground at fixed location. It's not mobile, it's not moving, and it's always access the satellite. Any user, okay, on the ground, we can use these satellites for voice, data, or a combination of these videos. Access the satellite through the Earth station. There is one Earth station on the ground, for example, here in Argisa. So all the users access the satellite through that fixed big Earth station on the ground. Such type of service, we call it fixed satellite service. Okay, it's used by internet companies, it's used by bank networks, and so many areas, private business networks, and so on. Another service, we call it mobile satellite service. In this case, the receiver is, as you can see here, it is transportable, right? If you take ships use satellite for communication, right? For navigation purpose and so on. They are moving from one port to another seaport. So it's movable, it's transportable receiver. if you take airplanes, they are using satellites for navigation, communication purpose, weather forecasting purpose, but they are moving, right? They are moving. So such type of service we categorized as mobile satellite services. Finally, we have a satellite service called broadcast. In this case, each customer directly access the satellite with small ground antenna. In your house, you are access satellite TV channels by putting one small antenna, dish antenna in your roof, right? You are not using any ground network. Direct TV reception from the satellite. Such type of service where, look here, it says what? Direct to consumer television, example, direct to consumer television. In this case, we are using what? We are using very small ground equipment. So in these cases, because the equipment we are using in our roof, the antenna is very small, 1 meter dish antenna, you can receive TV channels, right? So say type of communication it needs what? It needs high power transmission. It needs very high transmission power from the satellite, okay? For fixed satellite service, one big Earth station, so we don't need that much high power. But for broadcast satellite service, each individual customer directly connect with the satellite using small devices. In this case, we need high power transmission. So what do you understand here? The type of communication components depends on what? Depends on which type of satellite service. Is it fixed? Is it mobile? Is it broadcast? So what I'm trying to tell you is, before we discuss components of satellite communication system, the type of components we use in satellite communication system depends on two factors. First factor, it depends on orbit, okay? So when you choose a transmitter, is it for low Earth orbit satellite? Is it for geosynchronous satellites? Is it for medium Earth orbit satellite? It depends. The type of antenna we choose depends on the orbit. Another point, again, the components are depends on type of services we get from the satellite. Is it for fixed satellite service, like private networks, bank networks, international internet connection, okay? Gateway for any country. All these are fixed satellite services. So what type of components we use? In FSS and MSS is different. MSS, if your receiver is movable, it's mobile, it's not stationary, like airplanes, ships, and so on. The type of components depends on type of services of the satellite. That's the 2 points I want to discuss with you before we start these components. Okay. So, but in general, we can configure or classify components into two. Satellite components into two subsystems. Okay. So as we have discussed, the information, it doesn't matter. The information can be voice, it can be data, or video, or a combination of this. Okay. This data transmit, you can communicate it through, okay, this type of information here is our user environment. Another user environment, we have voice, data, video on this side, or a combination. You can communicate on the ground we call it terrestrial network. It can be wireless, right? It can be fiber. It can be copper cable on the ground. In addition to this terrestrial interface between these two nodes, we can use another network from here, from the satellite. It's one option. On the ground, we have how many options? At least 3 options: fiber, wireless, and copper cable, like coaxial cable and so on, twisted pair and so on. That we call this terrestrial network. Terrestrial means on the ground. In addition to this, we need one more additional link for communicating our voice, video, data, or combination of it. That additional link is a satellite link. Okay, so terrestrial link, satellite link. So here, the satellite components generally we categorize into 2. First one is the space segment, and the second one ground segment. It's divided into, we classify these components. Our chapter is components of satellite communication system. As I said, it's not same. When I say transmitter, satellite transmitter, it depends on the orbit, it depends on the service, right? The antenna we use for one service, antenna we use for another service is different. The receiver we use one orbit, the receiver we use in another orbit is different. But generally speaking, we classify these components into these 2 categories or segments. What is the first one? Space segment. All device equipment we put in the orbit. Okay, we call it space segment. And another one is ground segment. Components, devices on the ground. So generally, satellite subsystems categorized into 2: space segment and ground segment. We'll discuss these 2 one by one. We start from the space segment. When I say space segment, all components in the orbit. So this space segment again divided into 2. What are the segments in space? We classified as bus and payload. Okay, so what is bus and what payload means? The equipment devices in orbit again categorized into bus and into payload. So payload means equipment is used for communication services, right? Or remote sensing service. Equipments like transmitter or antenna or transponder, all these equipments which are intended to provide communication service, we classified them as payload. But the satellite, as you know, we put in orbit, it does not only contain communication equipment. There are additional components. When you see this satellite here, geosynchronous satellite, you see this one, these 4 solar panels. They are not used for communication purpose. They are what? They are used for power supply, because this device is in space. It's in space. We cannot connect a power from the grid on the ground. You cannot give it a line power. Where this equipment get power? From a solar panel here, which converts sunlight into electricity. Also additional batteries here. Okay, so this space segment consists of 2 parts. What is the first part? We call it payload. Payload means our transponder, our antenna. We classify this as payloads. They are designed, they are used for giving service, communication service from one Earth station to another station. That's their purpose. These equipments are categorized as under payload. There is another equipment under bus. We call them bus, additional supporting equipments. They give supporting function for the satellite. What type of equipment? Even this covering of this satellite, this structure, physical structure, batteries, power supply units, control units, okay, thermal control, power control. There are telemetry control. The speed of this satellite is controlled from ground, right? How we are going to control? There is a system here which is used to control and telemetry. So all these additional supporting devices, we classified them as bus. Okay. So in this chapter, we are not discussing the bus. What are the equipments under bus? The physical structure of the satellite, control equipments, the power system, thermal control, all these additional equipments, we classify them as bus. How about payloads? Payloads are our transponders. We'll discuss this in detail, and our antennas. These communication equipments are classified as what? They are classified as payload. So what we are going to do, we'll discuss from space segment, we'll discuss transponder and antennas. Okay. After we finish the space segment, we will come to the ground segment. What type of equipment, networks, architecture, all this we use on the ground, we'll come to that later. But now we'll start from the space segment. From space segment, specifically the payload. Equipment which are used for what? When you see here, bus is subsystem for what? For support to the satellite, not for communication purpose. Okay, the physical structure, power system, and so on, all they are used for supporting. How about payload? Payload used what? The communication equipments like transponder, antenna subsystem, and so on. Okay, all this we classify them as payload. So to revise what we have discussed so far quickly, this is our chapter 3, which says components of satellite communication system. The components in satellite communication system classified into two: equipments on the space, on the orbit, and equipments devices on the ground. We call them space segment and ground segment respectively. Space segment equipments again categorized into bus and payload. In this chapter, we are going to discuss the payload part of the space segment. First, the payload part of the space segment. What are the payload part of the space segment? The communication equipment in space, like antennas, transponders. We'll discuss that first. Next, we'll come to the another segment, we call it ground segment, components, equipments on the ground. Okay. And another thing you have to keep in your mind, components are not the same for all orbits. The type of components we use depends on two main factors. First, it depends on the orbit, and it depends on satellite services. We have discussed this so far. Now let's come to the payload part of the space segment. What is the first payload part? Communication equipment we put in space. We call it what? Transponder. Okay. From the space segment, we are going to discuss the transponder and the antenna subsystem in space. We call these two payload. Okay. The additional supporting equipments for control purpose, because we are communication engineers, we're concerned with the communication equipments part. there are power engineers, control engineers, industrial engineers. They are concerned about the other subsystems. Okay. That's why we focus only on the payload part of the space segment. Okay. So let's start from the transponder. It's heart of the satellite system. Here, let's start from the satellite transponder block diagram. So here we have antenna. We'll come to that, which receives signal from ground earth station using uplink frequency. There is an antenna here, receiver antenna. Okay, in this case, the frequency range is from 40.0 up to 14.5 gigahertz. So total bandwidth is 500 megahertz. Okay, how much bandwidth? 500 megahertz bandwidth. This is our uplink. Okay. Uplink, not downlink. So uplink from Earth station on the ground, this much frequency range. If you subtract 14.5 to 40, you will get 500 megahertz bandwidth. Okay, this can be one channel or it can be multi-channel. We have discussed this in chapter 2. Multiple access. We can transmit multiple carrier. This 500 megahertz signal to the satellite. Okay, the antenna part will come, but we'll discuss the transponder part. This transponder part is a communication equipment series of components, not one component. Okay, when you say transponder, it does not mean one individual component. It's interconnection of components together. We call it a transponder. What are these components? The first one is low noise amplifier. Okay, so as you can see here, I think you can see this device. Can you see it? It's low noise amplifier. Start from here. This is okay. I think now it's visible. Okay. So here we have our horn antenna. This is the waveguide, and this part, this rectangular part you see, is the low noise amplifier, LNA. Okay, low noise amplifier device I have here. This low noise amplifier device, if you can see here, it says what? It says gain how much? Can you see? Gain 60 dB, noise 0.6 dB. This low noise amplifier used in Q-band from frequency 10.7 gigahertz up to 12.75 gigahertz. Okay, this low noise amplifier. So you see here the noise level is 0.6 dB. Gain, it says 60 dB. So what does it mean? Low noise amplifier. It means what? It takes weak signal, very weak signal from the Earth station. The antenna receives very weak signal. Why? Because it's very far distance between the satellite and the Earth station. We need to amplify this. But when you amplify this low noise amplifier, all the signal comes from the antenna here. This is a horn antenna. All signal, very weak signal, including noise. Noise plus signal comes here. transmitted through this waveguide to the LNA. So the LNA amplifies both the signal and the incoming noise. It does not reject the noise. Everything which comes from the antenna side transmitted through the waveguide and amplified here. So you will get the output at this point. Okay, this is our output of the low noise amplifier. Okay, so how much time it amplifies? It amplifies gain 60 dB, very high gain. 60 dB, very high gain amplifier. This one, okay, low noise amplifier. What is the another smart thing about low noise amplifiers? You know, when you use amplifier, oscillator, they create noise, right? The device itself generates noise. But this device, parametric amplifier, low noise parametric amplifier, it creates very small amount of noise. That's why we call it low noise amplifier. Okay, it does not mean it filter the noise. No, all the filter signal, everything is amplified. How many times? 60 times, 60 dB, not 60 times, 60 dB. If you convert to linear, it is it's almost 1,000,000 times. Signal is amplified almost 1,000,000 times. 60 dB, 60, very high gain. Why we call it low noise? It's an amplifier, but it is low noise amplifier. Why we call it low noise? How much noise you can, if you see here, how much noise this amplifier generates is only 0.6 dB. Okay, another amplifiers, they generate too much noise. The device itself, not noise comes from outside source. Noise generated by our device is very high. Okay, but this type of amplifiers, low noise amplifiers, they generate a small amount of noise. Okay, so that is the first component in the transponder. When I say transponder, it does not mean one device. Transponder means series of devices connected together. We call it one transponder. So what is the first component in a transponder? Low noise amplifier, LNA. Okay. So what does it mean by, you can see here different type of low noise amplifiers. This is for GPS application, low noise amplifier. This is another type of low noise amplifier. It's another type. So this amplifier increases what? The power of both the signal and the noise present at input. It increases at the input, this antenna, it increases both the noise and the signal. But what makes it smart? Here, the last statement, it says what? LNAs are designed to minimize additional noise. This, you can see the specification here. This low noise amplifier, it only adds 0.6 dB. If it is visible, I can show you here. Noise, it's like this. No, it's like this. How much noise? Gain is 60 dB. Noise 0.6 dB only. Okay, so that's the first component of a transponder. So please keep in your mind, when we say transponder, I'm not saying only one component. It is series of components. Okay, so here you see transponder. Transponder is what? It is series sorry. Okay, so it is a series of components not one single component. That's what we call a transponder. So when you see a transponder, what is the first component we see is this low noise amplifier, LNA. You can find this device in many communication systems, low noise amplifier. So what is the characteristics of this low noise amplifier? It's not only for satellite. You can find this LNA, almost all communication systems, you can find this low noise amplifier. Okay. High gain, whatever comes to the antenna, this horn antenna, it amplified. How many times? As you can see here, 60 dB gain. But it amplifies both what? Both the signal and the noise present at the input. Here is the input, here is the output, the coaxial connector here. So, but LNAs, they are designed, they are called parametric amplifier. Inside here, parametric amplifier, they generate a very small amount of additional noise. Okay, if you use normal amplifiers, they generate too much noise. Amplifiers are noisy equipments, but LNAs are designed to minimize additional noise. Okay, what is the next component of a transponder? We call it frequency translator. In general, it's called frequency translator. Okay, the next component. First, what comes from the antenna? Okay, the next component is the LNA. It is amplified 60 times. In this case, okay, in this case, the gain is 60. That's the first component in the transponder is LNA. What's the next component? The frequency translator. Okay, so frequency translator, here the frequency which comes from the ground as uplink is from 40 to 40.5 gigahertz, right? Now this frequency converted into what? Here you see, from 40 gigahertz, 40 up to 40.5, decreases to 11.7 to 12.2. Frequency is decreased from uplink to downlink. Why we need to decrease the frequency? First, to avoid interference between uplink and downlink. Second, here these equipments are in space, so we need what? High power amplifier. So to minimize the size, the frequency we transmitted from space to ground must be minimum compared with frequency we send from Earth to satellite. Okay, always downlink frequency is less than uplink frequency. In this particular application, the uplink frequency is here. This is the downlink frequency.